Assalamualaikum everyone, welcome back to physics class. In this session, I have one word example for you that we can solve it together. Let's take a look to the question. A 500 watt kettle contains 300 grams of water at 20 degrees Celsius. Calculate the minimum time it would take to raise the temperature of the water to boiling point. And then for the second question, the kettle is allowed to boil for 2 minutes. Calculate the mass of water that remains in the kettle. State an assumption that you make. Given the specific heat capacity of water is 4.18 times 10 to the power of 3 joule per kilogram degree Celsius, and then the specific latent heat of vaporization of the water equals to 2.26 times 10 to the power of 6 joule per kilogram. Okay, let's discuss it together. Okay, we'll start from the question number 1. Here, 500 watt. So, what is the quantity of? Great, quantity of power. Power equals to 500 watt. And then the water is at 20 degrees Celsius. So, we can write it as the temperature equals to 20 degrees Celsius. Then we have to calculate the minimum time it would take to raise the temperature of the boiling point. So we have to find the time required until the water is boiling. Remember that the water is boiling at 100 degrees Celsius. So from these two given temperature, we can find the change in temperature. The change in temperature of the water is T2 negative T1. T2 itself is 100, negative 20 degree equals to 80 degrees Celsius. Okay. Oh yeah, I forgot one thing. The mass of the object, the mass of the object, we can write it here. The mass equals to 300 gram. Okay, then the specific heat capacity of water, specific heat capacity, the symbol of the specific heat capacity is the lowercase letter of C, the lowercase letter of C. We can find the time required to boil this water by relate the equation of the electrical energy and then the equation of the heat energy. Electrical energy, suppose it as E equals to heat energy. And then for the electrical energy itself, we can use the equation of electrical energy E equals to the power multiplying with the time. While for the heat energy, we can calculate it by using equation M times C times delta T. Remember that the lowercase letter is for the time, while the capital T or uppercase letter of T is for the temperature. The power given equals to 500, and T we can write it as T. And then for the mass, don't forget to convert the mass into the kilogram. Here, 300 gram equals to 0.3 kilogram. And then for C is 4.18 times 10 to the power of 3, while for the change in temperature or delta T is 80 degree. Okay, and we can find the time required by calculate all of this. T equals to 0.3 times 4.18 times 10 to the power of 3 times 80 over 500. You can calculate it by your calculator, and then the result is approximately 200.64 seconds. So here is the time required to boil the water into its boiling point. For question number 2, you can do it by yourself, and please write your answer in the comment section below. If you have any questions, please let me know. For other questions, we will discuss it to the next Zoom session. Thank you for listening and thank you for watching. See you. Bye-bye.